Good morning. In the previous class, we have already discussed about the electrical properties of two different types of solids. And in this class, our objective is to mainly discuss about the magnetic properties of different types of solids. Okay. So let us discuss about the magnetic properties of different types of solids. Always remember that a magnetic field is produced from the movement of some charged particles. Okay, so this is the main point. Okay, now the question is why we observe the magnetic properties for a specific type of solids. Okay, or which factor will going to determine whether a solid will going to produce or exhibit the magnetic field or magnetic properties or not. Okay, the answer can be obtained from the concept of movement of charged particle. Okay, so we already know that when a moving or when a charged particle moves, okay, then they will going to create some magnetic fields, or we can observe some magnetic properties because of that movement of charged particles. Okay, and in case of solids, we already know that solids are formed by some constituent particles. They may be atoms, molecules, or ions. And the molecules and ions are formed by what? Atoms or some elements. Okay, and an atom is actually formed by nucleus, and there will be some electrons. Okay, and the electrons are negatively charged particles. We already know these things, no? And again, one thing is that actually there are two types of movement of these electrons. Okay, that means this negatively charged particles, which is electrons here, they have actually two types of movements. One is they can form a orbit around the nucleus. That means they can move a circular part, okay, around that nucleus. And the second one is that the electron can rotate actually with respect to its own axis, like like our Earth. Okay, so in the case of Earth, there are also two types of movements. One is the Earth can rotate along its own axis, okay, or actually with respect to its own axis, because of which we actually the day and nights are occur. Okay, and the other movement is actually the Earth can actually rotate, or they can form an orbit around the sun. Okay, similarly the electrons also have these two types of movements. Okay, because of this movement of the electrons, that means this orbiting electrons and the spinning electrons, they will going to create a magnetic field, and the magnitude of this magnetic field can be represented by a magnetic moment. Okay, actually this is represented by a vector as shown in these figures. Okay, and actually the length of this magnetic moment actually represent the magnitudes, and the direction will going to represented by the arrow sign. Okay, and these these magnetic moments are like bar magnet. Okay, they behave similar like bar magnets. And remember one point, that the inherent magnetic properties of a solid, that means whether a solid will going to exhibit a magnetic properties or not, is mainly depends upon the second movement, that is the spinning of that electrons. Okay, let's suppose we have two electrons or one pair of electrons in one orbitals. Okay, because we already know from Bohr's hypothesis that maximum 2 electrons can be present in one orbital. Okay, in atomic orbital, actually one atomic orbitals. And also we know that their spins are opposite in directions. Okay, so what will be the effect of this? The effect of this will be that magnitude of the the magnitude of the magnetic moments are same for both of that those two electrons. Okay, but because their spinning directions are opposite, so they are they will going to cancel each other. Okay, the magnetic moment will going to cancel each other, exhibiting no magnetic properties. That means we are not able to observe magnetic properties if the orbital is filled by 2 electrons. So that means only unpaired electrons can exhibit magnetic properties. Understand? and the value or the magnitude of these magnetic properties can be measured, and the units of this is actually known as Bohr magneton. Okay, and it is represented by mu b, and the value of 1 Bohr magneton is equal to 9.27 into 10 to the power minus 24 ampere into meter square. Additionally, there are, we already know that there are total two types of movements. One is actually orbiting movement and other is spinning movement of that electrons. Okay, and actually the first one is known as orbital angular momentum, and the second is known as the spinning orbital angular momentum, because they have actually the movement is actually angular. Okay, so they are known as angular momentum. Actually the momentum of that that movement is known as orbital angular momentum and spinning orbital angular momentum. Now coming to the classifications of solids on the basis of these magnetic properties. Okay, so on the basis of the magnetic properties of different solids, they can be actually classified into total 5 categories. Okay, and they are paramagnetics, diamagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic. The first category is paramagnetic solids, and actually the the phenomenon which is exhibited by these paramagnetic solids are known as paramagnetism. In case of paramagnetic solids, they only have one or more than one unpaired electrons, so that means they have less amount of unpaired electrons. In case of paramagnetic solids, actually they exhibits their magnetic properties in presence of only magnetic fields. Okay, external magnetic fields. If external field is not present, that means absent, then they will not exhibit magnetic properties. Okay, and if the external magnetic field is present, then they are actually the direction of the magnetic moment of that paramagnetic solid is in the same direction of that external magnetic field. Okay, and in case of paramagnetic solids, they are weakly attracted by the external magnetic fields. Okay, some well-known examples of these paramagnetic solids are oxygen, Cu2 positive, Fe3 positives, Cr3 positives. Okay, now let us discuss about the second types of solids, which is diamagnetic solids. Okay, so actually diamagnetic solids are repelled by the magnetic fields. Okay, so it is not like paramagnetic substance. Okay, in case of paramagnetic substance, they are weakly attracted by the magnetic field, that means an external magnetic field, but in this case it is opposite. Okay, and some examples of diamagnetic solids are water, sodium chloride, benzene, etc. Okay, actually in case of these diamagnetic solids, actually they lost their magnetic behavior or magnetic properties, because actually the electrons, all the electrons which are present in such solids are paired. Okay, so we cannot get any magnetic behavior, because we already know that the net magnetic behavior of a substance is observed only if unpaired electrons are present in that substance. Okay, so we cannot observe magnetic behavior in case of diamagnetic substances. Okay, understand? The third category is known as ferromagnetic solids. Okay, and some examples of ferromagnetic solids are iron, cobalt, nickel, chromium oxide, etc. Okay, and they are strongly attracted by the magnetic field, external magnetic field, and along with these strong actually attractions, they can be actually magnetized permanently by using some external magnetic field. Okay, additionally, in case of ferromagnetic solids, the metal ions which are inside that solids, they group together and they form some domains, and these domains are like some bar magnet. Okay, some teeny bar magnets. So that means in one domain they will going to behave like what, they will behave like some magnets. Okay, but the thing is that in the absence of some external magnetic field, the domains will orient randomly. Okay, so their direction will be random. That means they can cancel each other magnetic movements. As a result, there will be no any magnetic behavior observed in case of ferromagnetic solids in absence of external magnets. Okay, but in the presence of external magnet, the domains will going to orient in one direction. Okay, actually in the direction, in the same direction of that external magnetic field. Okay, and they will going to attract with each other. That means the ferromagnetic solid will going to strongly attracted by that external magnetic field or the external magnet. Okay, so again, when we remove that external magnetic field, okay, then what happened, that those domains will remain in the same directions. Okay, that means they will going to orient at the in the same directions. Okay, so as a result, they will going to actually behaves like a permanent magnet for sometimes. Okay, and because their orientation is same for sometimes, or the orientation is in the same direction for sometimes, so they will going to act like a permanent magnet. So they can even attract some other ferromagnetic compounds like iron. Okay, so fourth category is antiferromagnetic, okay, substance. So the antiferromagnetic solids, example manganese oxide. Okay, they also have some domains. Okay, and similar domains like ferromagnetics, but the orientations of the domains are opposite to each other. Okay, so because of these opposite orientations of the domains, they will going to cancel each other's magnetic moments. Okay, so because of this, they will not going to exhibit magnetic behavior. Fifth and final category is your ferrimagnetic solids. Okay, and they also have some domains, but in case of this substance, the domains are, some domains are parallel to each other and some are anti-parallel. That means between or among these domains, some are in same direction and some are in opposite directions. Okay, so actually in the presence of a magnetic field, actually they are attracted by that external magnetic field, but the strength of this attraction is not as strong as ferromagnetic substances. Okay, some examples of these types of solids are magnetite, ferrites, etc. Okay, and interestingly, these ferrimagnetic substances, they lost their magnetic properties on heating, and they will behave like paramagnetic substances if you heat them. Okay, because the applied heat actually randomizes the magnetic moment more. So this is all about the different types of or different categories of solids, which is classified on the basis of magnetic properties. Hope you understand all of them. And this is actually the last topic of your first unit. So in the next class, we will going to discuss about some new topics from new chapter. Okay, thank you.